Welcome back. In this one, I'm going to show you how to find the product of these three complex numbers by converting them into exponential complex form, and then also by using the unit circle. I got the unit circle just so you know from Wikipedia. So here, let's take a look. I'm going to proceed as follows. First step. That number I, I'm going to rewrite as just 0 plus I. So why would I do that? Because it will help me to recognize the angle that corresponds to that number. Okay, that second number, 1 minus the root of 3i stays, and the third number, root of 3 plus I also stays. So right now the goal is to convert each of those into r times e to the I theta. Let's go through that process. I'm going to focus on the middle number, so 1 minus the root of 3i, just because 0 plus I is really easy to handle. When I do 1 minus the root of 3i, remember I need the value of r in that position. So I have to apply the Pythagorean theorem. And the reason is, remember that basically the real part is like the horizontal leg of a triangle, and this imaginary part, the negative root 3, is like the vertical leg of a triangle. That's all it is, you see. So use the Pythagorean theorem to find the modulus, or like, if you like, the length of the number. Alright, with that in place, let's continue. I'm going to have the following. So the root of 1 squared plus negative 3 squared. Pythagorean theorem, just plug in. Next part, 1 minus 3 over here. Okay, work that out. That's 4, and then the root of that is positive 2. I have to repeat this calculation also for the root of 3 plus I. Let's carry that step out. So I'll have the root of 3 plus I. Again, plug into the Pythagorean theorem. So the root of 1 squared plus the root of 3 squared. Nice. Next one, 1 plus 3. Good. Okay, which is the root of 4, which at the end is just 2. That's working very nicely thus far. Let's convert actually each number now over here into this exponential form. We have not yet done that, I meant to say. So here, 0 plus I. That's going to look like the following in exponential form. Well, the magnitude of 0 plus I is just 1. So in front of the e is a 1, okay? It's not written, but it's present. And then you have I times pi over 2. Where's that pi over 2 coming from? Look back over here at the unit circle. You see, at pi over 2, which here is kind of above my head, you have the point 0, 1. So that 1 that you see there above my head, that corresponds pretty much to like 1 times I. Okay, that's why there's a 1 there. That corresponds to pi over 2. So back here, that's why it's e to the I pi over 2. Let's handle 1 minus the root of 3i. That's not so obvious. That requires more work. That's going to look like 2 times e. That 2 is the 2 also in that position. I get that from the Pythagorean theorem because it's the value of r, which multiplies e. So I have 2 times e to the I, negative root 3, negative pi over 3 rather. So where's that coming from, that negative pi over 3? It's not obvious. So over here in the picture, take a look at something here. The number is 1 minus the root of 3. So what you can do is with the tangent function, essentially. It's as if you took this imaginary part and you divide it by the real part. It's just using the tangent function. It's just a ratio of y to x coordinates, and that's it. So you just have to find the right angle that corresponds to that right ratio. So here would be negative root 3 over 1, which would still be negative root 3. So over here, I'm looking for an angle where the tangent is negative root 3. So you have to be really careful because when you deal with the unit circle, there's so much happening here. Usually for these arguments, or the angles, in other words, these values that go up there, you're looking between negative pi and positive pi. So for that reason, take a look. I'm going to proceed as follows. I'm going to go backwards from the point 1, 0 and take a look at something. I'm going to go down to what appears like 5 pi over 4. Or rather 3, but that's not the right angle. Right, take a look at the ratio of the coordinates. If I do negative root 3 over 2, and if I divide that by 1/2, the 2's will cancel, and you will end up with negative root 3, you see? And that will correspond to this negative root 3 over 1. So that's good. You just have to read this the right way. So because of the way things have been set up, you don't want to put in 5 pi over 3. Instead, you only count from the point 1, 0 in this direction, the way I'm moving, and stop at what appears to be 5 pi over 3, but I need to count the angle as a negative quantity. So if you look very carefully, that blue point, 5 pi over 3, that's the mirror image of that blue point above my head right now at positive pi over 3. In other words, you see this is 1/2 for the x-coordinate at pi over 3. It's 1/2 for the x-coordinate at this other angle here, which right now is 5 pi over 3, but in a second is going to be negative pi over 3. Then up here at positive pi over 3 is the root of 3 over 2, which means down below it's negative root 3 over 2. which means you don't want to see this as 5 pi over 3. What you really want to see is just negative pi over 3, as if you went 1 comma 0 down this way. That's why over here now it says negative pi over 3. The last number is the root of 3 plus I. Okay, let's work that out. So again, I need to look as follows. I'm going to have that 2 above my head there. That's coming from doing this calculation with the Pythagorean theorem. It's r. In other words, it's that value of r in a general kind of like complex exponential number form. And I'll have e raised to the I and then pi over 6. Why is it pi over 6? So remember, this says that 1 is really, that I rather is really just 1i. And then you have the root of 3. So you're looking for something where the tangent is 1 over the root of 3. So if you look back at over here at pi over 6, if you take the y coordinate there, which is 1/2, and you divide by the root of 3 over 2, you will see that will give you what you need, because the ratio of 1 over 2 to the root of 3 over 2 is 1 over the root 3. And back here, remember, this number is 1 from in front of the I divided by the 3 in that position, the root 3, that's 1 over the root of 3. So it corresponds to pi over 6 for that reason. So what we have then essentially is this. Instead of multiplying these complex numbers, we're going to multiply the exponential form. So you do that simply by taking and multiplying the r's together. So the first, in front of that first e is 1 times 2 here, which is 2, times 2 is 4. So down below me, see there's a 4 in front of everything for that reason. And then what you can do is just add up the numbers in terms of the angles. So pi over 2 plus negative pi over 3 plus pi over 6. And you see that below me. The I, make sure you copy that only once and close the sum of the angles inside of parentheses. And this is what it looks like now. So keep the base, add up the angles, multiply the numbers in front of the e's. Let's continue. So now we have to work out the value of this expression here. Pi over 2 minus pi over 3 plus pi over 6. So up here I'm going to have pi over 2 minus pi over 3 plus pi over 6. Let's work that out. So first I'm going to convert pi over 2 into 3 pi over 6. Why would I do that? Because I look at my denominators over here and I see that I can use 6 as a common denominator. So I convert pi over 2 to 3 pi over 6 for that reason. For the next one, I'm going to convert negative pi over 3 into negative 2 pi over 6. Same bottom now. And the last part, that plus 6, pi over 6, can be kept as plus pi over 6. No problem. Next, work this out. So copy the bottom ones. So 6, and then you have 3 pi minus 2 pi. Plus another pi, that's going to give you 2 pi at the top. So simplify 2 pi over 6, so that becomes now pi over 3. So that's the angle of the final multiplied out number. That's essentially what that is. And what you can do then is the following. This value, which right now is below me, where all of the angles are written in terms of mathematical operations, can now be written more simply as 4 times e to the I pi over 3. Let's think about this for a second. Go into the unit circle over here, into that world. Okay, look for pi over 3. That's right here. Pi over 3 is above my head. And you see that 1/2 is the value of the x-coordinate. The root of 3 over 2 is the value of the y-coordinate, which means over here it's going to become the following now. 4 times 1/2. So I'm switching from exponential to this complex number form, if you like. So here you're going to put the x-coordinate in this position, plus the value of the y-coordinate from the unit circle multiplying I, essentially. Then take a look. You have 1/2, and then under that root 3 you have a 2. Again, that really means though 1/2 times the root of 3. So to divide by 2, remember, is the same as to multiply by 1/2. What that tells you then is that from 1/2 and the root of 3 over 2, you can factor this 1/2 out, leaving inside the parentheses 1 plus the root of 3i. So close. Now you're going to do 4 times 1/2 in front of everything. That's going to give you here that 2 below me in this position. And then the rest of it is just kept exactly as written. So 1 plus the root of 3i. And that is the final answer after all of the mathematical stuff that we've done. Okay, this is a lot of work. I hope it's been somewhat interesting. Please leave a like and subscribe, and I will see you in another video.